In this video, we will cover questions number 6 through 10 on the January 2023 Algebra 1 Regents. Make sure you grab a notebook, a pencil so you can take detailed notes, and where possible, I will show you two solutions. It'll be one that is an algebraic approach and one where we can leverage the use of the TI-84 graphing calculator. You'll notice some questions don't require the calculator at all, but where possible, I'll make sure to incorporate it. Let's get started. For question number 6, it says, what is the value of the third quartile in the box plot shown below? Let's do a quick review of a box and whisker plot. There are 5 core points that you need to be aware of. This first point right here is always going to be the smallest value in the list of data points. This is the smallest value right here. So we can tell that the smallest value here is 14. This number right here is going to be the largest value. So we can tell that that number is right between 44 and 50, but let's try to figure out what our scale is. If we're going from 44 to 50, that is 6 points, and we see 3 different tick marks. So we're going by 2. So 44, 45, 46, 47, 48, 49, 50. So this number right here is 46. That is our largest value. Right here is going to be the median of the entire data set. Remember, the median is the middle number. So be mindful of that. We can also call this the second quartile. We'll get into this a little further when we do the review of the box and whisker plot. Right here is going to be the first quartile, which is actually the median of the first half of the data set. And this number right here is going to be the third quartile, which is the median of the second half of the data set. We can tell that the first quartile is 18 because we're counting by 2s on this number line, and the third quartile is 36. So our answer is choice number 3. Let's move on to the next question. For question number 7, it says, what is the solution to 2 plus 3 times 2a plus 1 equals 3 times a plus 2? Let's solve this equation. We have 2 plus 3 times 2a plus 1 equals 3 times a plus 2. My first step here is going to be to apply the distributive property. The distributive property will allow us to multiply 3 by 2a plus 1 and 3 by a plus 2. So let's go ahead and multiply. We have 3 times 2a, 3 times 1, we have 3 times a, and 3 times 2. So now we have 2 plus 6a plus 3 equals 3a plus 6. And let's combine like terms. Our like terms on the left-hand side is 2 and 3. So now we have 6a plus 5 equals 3a plus 6. And our goal here is to get the variables on the left and the numbers on the right. So let's subtract 3a on both sides. And let's subtract 5 on both sides. Why did I make that choice? Since 6a is larger, it would be much easier to bring the smaller variable term to join 6a so that you have a positive variable term. And then, of course, we're going to move the constant or the number without a variable over to the right. So we subtract 5 on both sides. Guys, notice that 5 minus 5 cancels out and 3a minus 3a cancels out. So what are we left with? We have 6a minus 3a is 3a, and 6 minus 5 equals 1. We're still not done yet, guys. We're not solving for 3a. We are solving for a. So we will go ahead and divide both sides by 3. Our final answer is 1/3, and that is answer choice 2. In the event that you are struggling with solving equations, which I know that it can be possible that this can be a bit challenging for you, I want to show you a way that you can use the calculator to test out the values. Let's head on over. So let's say you wanted to test out these values. This is a bit cumbersome, but it is a way that you can go ahead and plug in values. So let's see, we have 2 plus 3, open parentheses, 2 times A, right? The first A value is 1/7. So we have 1 divided by 7. And then we're going to go ahead and add 1. So let's just double check to make sure our work looks correct. 2 plus 3 times, that means open parentheses, 2 times 1/7 plus 1. We need to have a close parentheses. So what answer do we get? We have 5.85714. We're going to go ahead and test out the right-hand side. We start off with 3, then open parentheses. I'd like to show you a different way you can enter a fraction. The first way was just division. 1/7 would be 1 divided by 7. Another way is to press the alpha button right here, which you know will access anything in green. And then we're going to press the X button because if you notice, this is the fraction icon right here. So now we have 1/7 in our parentheses. We're going to press arrow right to continue typing in the answer here. And so now we have 3 times 1/7 plus 2. And that gives us 45/7. But let's say we want to turn that into a decimal. We're going to press math, go down to 2, and then press enter. So if you notice, these two values are not equivalent. Therefore, 1/7 is not a solution to the equation. Let's try answer choice 2. We have 2 plus 3, open parentheses, 2 times, right? Anytime we want to multiply, we can always put it in parentheses. And this time we're testing out the value 1/3. So that's 1 divided by 3. We close the parentheses, we're going to add 1, and we see our final answer here is 7. So we are hoping that when we substitute 1/3 on the right-hand side, we're going to get the value 7. Let's see. We have 3, open parentheses. I'm going to put the fraction 1/3 in parentheses just to avoid any mistakes. We have 3, open parentheses, 1/3 plus 2, close parentheses. Look at that, we got 7. So it looks like 1/3 is an appropriate solution to this equation. I would recommend, if you do choose to use this strategy, that you test out all 4 values just to make sure. Remember, when you're entering answer choice 3 and 4, use the negative. I can model one of those problems here for you. Let's say we have 2 plus 3, open parentheses, 2. I'm going to use another parentheses to multiply 2 times A, and we're going to use the value -3/7. So negative is right here. We have -3 divided by 7. We're going to close our parentheses, then we're going to add 1. Okay, so we have 2.428. Then we're going to test out the right-hand side. We have 3, open parentheses. We're going to use another parentheses to enter the fraction, -3 divided by 7. Close that parentheses, and then we're going to go ahead and add 2. And you'll notice that these two values are not equivalent. So -3/7 is not a solution. So we already know, because we solved algebraically, that 1/3 is an appropriate solution, but also when we tested out the value by substituting 1/3 for A, we were able to see that the left-hand side of the equation was equal to the right-hand side. 7 equals 7 when A is equal to 1/3. Guys, you can choose which strategy you want to use. You have 3 hours on the Regents, so you have time, okay? So if you decide to test out values, you can. It is my preference that you learn and master the algebraic approach. Let's head on over to question number 8. For question number 8, we have a real-world scenario. One Saturday afternoon, 3 friends decided to keep track of the number of text messages they received each hour from 8 a.m. to noon. That's a total of 4 hours. The results are shown below. Emily said that the number of messages she received increased by 8 each hour. I'd like to use a table of values to represent the information that the students are sharing. X will represent the hours, and Y will represent the text messages. Let's assume that the initial number of text messages were 2, and then we'll go up from there. So at hour 0, We're starting off with 2 for each of the scenarios. Emily said that the number of messages she received increased by 8 each hour. So after hour 1, she would have 10 text messages. And then after hour 2, she would have 18. And after hour 3, she would have 26. So we can see that her text messages are going up by 8 every time. Let's take a look at Jessica. Jessica said that the number of messages she received doubled every hour. So if she started off with 2 text messages, after 1 hour, she would have 4. After 2 hours, she would have 8. After 3 hours, she would have 16. So we have a doubling behavior here. And Chris said that he received 3 messages the first hour, so he would go up to 5. And then 10 the second hour. Now he has 15. None the third hour, so he stayed 15. And 15 the last hour. So now he's up to 30. Let's take a look at how his text messages are increasing. He started off with +3, then +10, then +0, and +15. Guys, I hope you remember that for linear functions, the numbers will add or subtract by the same amount every time, okay? So I'm looking at Emily's, and that one looks exactly like a linear function. We're adding 8 every single time. However, for exponential functions, we will multiply or divide by the same number every single time. This is one of the biggest topics that is covered in the Algebra 1 Regents, the difference between linear and exponential functions. For linear, we're adding or subtracting by the same number every single time. For exponential, we're multiplying or dividing by the same number every single time. Of course, Chris, that doesn't make any sense because for Chris's example, the number's changing every single time. So that's not linear. It's not exponential. It's basically nothing. So definitely don't be fooled by his representation. So for the final question, it says, which of the friends' responses best classifies the number of messages they receive each hour as a linear function? So the correct answer here is Emily, because Emily is the only one that classified the number of messages they received as a linear function. Let's head over to question number 9. Question number 9 states, which expression is equivalent to x plus 4 squared, in parentheses, times x plus 4 cubed? This is basically an exponent problem. I'll show you a simpler example first. Let's say you have 3 to the 5th power times 3 to the 3rd power. If we were to write this in expanded form, we would have 3 times 3 times 3 times 3 times 3, right? And then we're multiplying that times 3 times 3 times 3. How many 3s do we have in total? We have 1, 2, 3, 4, 5, 6, 7, 8. So that is 3 to the 8th power. All we do is write 3 to the 5 plus 3, which would give us 3 to the 8th power. We go ahead and we add the exponents. Let's say we were working with variables. If we had x squared times x cubed, we would have x times x times x times x times x. How many x's do we have in total? We have 5 x's. So this now becomes x to the 5th power. Guys, we can use this exact same approach to solve our problem. We can go ahead and just add the 2 exponents to give us 2 plus 3 equals 5. Now let's give this problem a try. We have x plus 4 squared times x plus 4 cubed. They share the same exact base. So we have x plus 4 to the 2 plus 3, which is x plus 4 to the 5th power. So our correct answer is choice 2. I'd like to show you a way that you can determine equivalence using the graphing calculator. So to determine equivalence, we're going to treat each one of these expressions as its own function. Let's head on over to y equals and we're going to test out which answer choice is going to be correct. We'll start by entering the initial expression right at the top. So we have open parentheses, x plus 4, close parentheses. We're going to square that. Now we have another open parentheses, x plus 4, close parentheses, and we're going to raise that to the third power. This is our given expression, and we want to see which answer choice is equivalent. So I'll start by putting answer choice 1 into y2 equals, right? So we have open parentheses, x plus 4, close parentheses. We're going to raise that to the 6th power. And let's go ahead and take a look at the table to see if they're identical. If you look at y1 and y2, 1 is equal, but 32 is not equal to 64. 243 is not equal to 729. These y values are not equivalent. So that's not the correct answer. You have the choice of entering all 4 answer choices into y2, 3, 4, and 5. I believe I showed you that in a different video. Or for some people who prefer to not see so many numbers and variables in one screen, you can test them out one at a time. So let's go ahead and test out answer choice 2. X plus 4 is exactly the same, but this time the exponent is 5. Let's take a look to see if they're exactly the same. And if you look at y1 and y2, the y values are identical. So that's how we know that answer choice 2 is correct. You can go ahead and test out the other values just to be sure. But this is a great strategy just to make sure that you're not making any mistakes and you have the correct answer. I'll show you answer choice 3 just to make sure you know how to enter it into the calculator. We have open parentheses, we have x, we're going to square that. Then we're going to add 16, close the parentheses, and now we're raising it to the 6th power. Now let's check out the table of values. Again, when we look at the y values, they are not equivalent. So when we're identifying equivalence, you're trying to find the expression that is exactly the same. So we can double check to see if these y values are equivalent. Let's check out question number 10 next. Question number 10 says, Caitlin graphs the function f of x equals ax squared, where a is a positive integer. If Caitlin multiplies a by -2 when compared to f of x, the new graph will become. Let's talk about function transformations in this video. Let's say you have y equals x squared, and it looks like this, right? That's going to be a parabola, right? This is what y equals x squared is. And anytime you multiply any function by -1, right, which means it's going to have a negative in front, it's going to be reflected over the x-axis. So this graph is going to be y equals -x squared. Again, this is a reflection over the x-axis. So that's the first thing I noticed. I noticed that there's a negative here. If we're going to multiply x squared by a negative, it's going to open downward. So automatically, I can eliminate answer choice 2 and answer choice 4. So now we just need to determine how will the 2 impact this actual function. There's a rule that when you multiply a function by a number greater than 1, it actually makes the function narrower. So our parabola will look something like this. So this function here would be y equals -2x squared. So we know for sure that answer choice 3 is incorrect, and the correct answer is going to be answer choice 1. I also want to add the case when the function would get wider. That would be when you multiply the function by a fraction. For instance, if we have y equals, let's say 1/4 squared, it's actually going to look something like this. Y equals -1/4 squared. Okay, it's going to get wider. So anytime this is a fraction between 0 and 1, the function gets wider. Anytime it's a number greater than 1, right? We're multiplying the function by a number greater than 1, it's going to get narrower. Let's head on over to the calculator to take a look at some of these function transformations so we can see a visual. So our first function starts off as y equals x squared. Let's take a look at what that looks like. This is y equals x squared. Let's go ahead and multiply x squared by -1. So we have y equals -x squared. Take a look. It was reflected over the x-axis. Now we're going to go ahead and multiply it by 2. So we have -2x squared. Let's see what it looks like. Notice it got narrower. I want to show you just how narrow it can get. So let's try -5. -5x squared. You see how that pink graph got even a little bit narrower? So the bigger that coefficient gets, the narrower the function gets. Now I'd love to show you what it looks like when it gets wider. I'll apply this to the x squared function. Let's try 0.5x squared. We want any number that's between 0 and 1. Notice it starts to get wider here at the top. Let's try 0.25, which is 1/4 x squared, and see what that looks like. This is going to be the orange graph. And notice it got even wider. So as that coefficient gets closer and closer to 0, the graph starts to get much wider. Make sure you pay close attention to these function transformations and you do your best to study all of the different ways that functions can be transformed. If you like this video, please like, comment, share, and subscribe. Make sure you watch all the videos in this series because it's going to get you through the full January 2023 Regents. And if you have any questions for me or any video requests, you can post them down below or shoot me an email. See you in the next video.